Alright, so this video, or this stream video, um, still working with my OpenGL C++ program, still a new coder, still learning, and now we have waves. Trying to work with water, actually, right now. I don't know, I had the urge to work with water and animations, so I think I'm gonna stick with water and animations. Right now, this is just a simple wave, um, and I could change it based on a lot of things actually. And all I did was implement a texture, simple texture, and propagate the waves. So it's actually um, not propagating like left, like it's not going this direction, it's only going one direction right now. But there's a couple things that I could try to do. I've actually implemented a way to reload the shader as I'm working on it. That way I don't have to keep closing it. And we're gonna put this guy up here. So what I ended up doing, it's all hard coded for right now, but I could use the uniform variables to implement this later. Um, I actually used a real-time parametric shallow wave simulation equation, and I'm only calculating the y for now. I'm not entirely sure if I did it for the x too. We could go. I was thinking about trying that right now. But we have the distance, we have the positions, we have the timer, we have the depth, amplitude, velocity, wavelength, variance, steepness, and steepness variance as well. And then you have the phase. This needs to stay the same. It's basically 2 pi divided by the wavelength, or times velocity divided by the wavelength. Then you adjust the wave, you adjust the steepness. I actually have it in adjust steepness. Dot the result, get a float, and do some other calculations to it that do cool things to it, and return the final value. It goes up here into um, my position vector, or my position matrix. And so, as I mentioned, I didn't implement for the X, but what I'm going to go ahead and try to do, I'll probably have to do a different value. I'm just going to see what this does for now, if I do it for the X and Y. And we're just going to reload that real quick. And yeah, I figured it would do something like that. Because, yeah, we have to do a different calculation for that. So we can go back and put it back how it was. So if we're gonna do the X, I need to implement other things, and I can't hard code it, I don't believe. So I might be able to hard code it, maybe. Probably not. Nah, I'm just gonna leave it. But yeah, so I got waves. And let's see, can I make the depth? Let's see what I can do with the depth. I'm not even sure. I'm just like playing around with these now. And I think the depth doesn't really do much. Actually, there's something else I could do. And it's an if statement. And vertex position dot y is greater than a certain value, then do this. And we'll see what this does. And then else, can't type. We'll make the vertex wave equal to Yeah. So vertex position, vec2, and then vec y, vertex y. So let's just see what this does real quick. I'm assuming it's going to increase the amount underneath here instead of just being flat. So let's see what that does. Make sure everything's right, otherwise it's going to close. Oh, it's a float. We don't want a float. Um, yeah, I don't know why I did that. We just want the y because we're changing the y. So yeah, there we go. D-wave float, so making that a float. Yep, okay. So let's see what that does. Oh, and it looks like I made a mistake here. Oh, yeah, totally made a mistake. Oh, I don't know why I started. Okay, so vertex wave, vertex position y, what? What did I change? So did if statement, set that equal vertex position, vertex, else vertex wave. I've already defined it. Actually, let's just do this. That might be y. And we'll close that guy off. And everything else should be fine. Yeah, so I just defined it twice. And let's see what that does. And it didn't do much. Didn't do anything. It actually just, well, you could see that it cut off. It didn't cut off from, it's actually not flat anymore. You can see it has a little volume to it. So I wonder if I only made it the top parts of this available to change, that what that would do. Didn't do much. Still got waves though. I mean, waves are good. I want to propagate the x as well, but when I propagate the x, actually when I propagate the y or the x, let me show you what this actually, well, I don't know. Well, let's see if it, let's just do, make this 13, and this is what it actually looks like for the texture. So it's cutting off all of that when I run it through this function. So I'm assuming that it actually I'm not even sure why it does that yet. I have to think about that for a little bit. Well, let's see. So I send it in, I send the vertex positions in x and y, and I have a direction. Interesting thing is the water depth doesn't seem to matter. Well, amplitude? No, because that's the amplitude, velocity, no wavelength, no steepness? Possibly? Possibly could be the steepness. Let's give that a try. So let's set that back. And we'll make the steepness 3. And we'll reload that. And no, that's just the steep. I'm not even sure what the steepness really does in this with the hard-coded uh, stuff I have here. So, let's see if it makes a difference. Well, it raised it. You could tell it raised it. But there's something else lowering it. And it might be the variance, possibly? So if we make the variance 1. Nope, that didn't do anything. 23 maybe? Oh wow. Oh, you can see what it's doing now. See the wave steepness? It's like, that's totally what it's doing. So there's just larger waves. Okay. Let me see here. Let's change that back to 1. We'll go back here, reload. Yeah, see that? The steepness of the wave there. Okay, so I know what that does. Let's see what the variance does. So the variance is how quick it moves. Ha, that's pretty cool. That's so cool. Okay, I'm just playing around with this stuff. So let's put that back. Wavelength. Let's make that 5 and see what happens. Oh, longer waves. Well, longer waves over time, I suppose. Okay, so the velocity is how fast it's going. Amplitude, we can raise the amplitude to 0.6. Higher waves. Okay, so it looks like it's the amplitude. It's starting from the bottom, and because I have the textures actually going from like this point down to this point, the higher it looks like the amplitude's actually lowering that to the very bottom for some reason. It's probably just how the equation actually works. I'm not even sure. Like, depth didn't do anything last time. Let's try that again. Aha. Whoa. They look like... It doesn't look so smooth anymore, does it? Well, depth is interesting. What else can we do here? We don't want to change any of that. We can try changing the direction. I guess if those aren't uniform, it'll make very strange textures. Or not. Let's go up to... Okay, let's do 15. See what happens. Oh, now it's going backwards. Oh, that's interesting. I don't like the way it looks, though. Wait, is that going backwards? It's going backwards. Or opposite direction. So what had... I think it was the steepness? Yeah, so now if I change the steepness with that, it adjusts for it, but... it still looks kind of blocky. And I think that's it has to do with the distance between each vertice. raise the amplitude a little bit more. See if I could try to smooth this out. Let's make the wavelength larger. And no, definitely not going to smooth out. Let's just play around. So now if I switch these back to 1, it'll be really, really strange. Ooh, big waves. Alright. This is a pretty cool equation. It's actually fun seeing what equations actually do in real time. Like you can't really do that on a a calculator, but you could do it on here, and you could sit around and play with it all day. I do like the way this is this looks though. If I could find a way to actually change the have it go in the X direction as well, that would be really cool. Not entirely sure how to do that. I wonder if I sent in the X and the Z coordinates, and then, well, I don't think that'll matter because I dot them anyway, so it's going to turn into a float. But if I dot them with the direction, then it's just going to give me probably a larger number, more than likely. Well, it could give me a smaller number if the Z coordinates are negative. I'm not sure if that'll even matter. It won't do what I want it to do. So, think about this for a second. So right now I'm only taking the Y. So the only thing changing is the Y. The X and the Z coordinates stay the same. The Y is changing. As it should. Because, the X and Z is the area of my pool, if you will. So where the fluid is, that is my area. So those should not change. Like, if those change, then it'll do what it did earlier, and obviously I'll have a 0 or a very small number for my area. So it's definitely the Y, so you definitely want to change only the Y, but how do you propagate the wave so it's moving towards you in this direction? It's not just moving in one, I think it's moving down the Z right now. It's either the Z or the X, but let's assume that's the Z, and then I want it to move on the X as well. Not entirely sure. I suppose that I could put some if statements in there. Because I could make it go in the negative, well, negative direction would just go backwards. So I'm doing the, let's see here. So I'm using a sine function. And that is why it's only going in one direction, is because of that sine function. So if I wanted to propagate it a different way, I'd have to have a different angle for my final A. because that is the angle in which it's moving, right? So if I put a 1, I think this will work. Let's put a 1 there and see what happens. Oh, not 1. We don't want to do a 1. Why am I a 1? Sine a 1. Come on now. Let's do. I think it reads, and it might read in degrees. We'll see. Yeah, degrees. So let's do 45.0f. Oh, because it's a static number now and it's not changing over time, so I could put time in there and we'll see. Oop, timer. And then go. So down and up, down and up. So it definitely has to do with the dotting of my direction and position. And probably 2 pi over the adjusted wave. So I'm making a wave in one direction. Uh, What if what if what if is the question. That's my final A. So we'll just do that. And let's see. Yeah, anyways, like, it'll be something I play around with. I actually wonder if I multiply this by the cosine of time. How about negative time? Doesn't matter. We could possibly do the sine of time times 45.0f times 0.01 f divided by time. It's not loading. That's weird. Vertex wave sine time times that divided by that. Weird. Doesn't look like my... Let's see if this does anything. Yeah, it doesn't look like my shader's reloading for some reason. Unless... change that to 1. Yeah, Still reloading. That just didn't matter because I was changing. Oh, I was doing the fragment position. Wow. Okay. Um, so times the sine of time times 45.0f times 3.14 times f 0.01f. Now it propagates underneath. How? Maybe it's not pi. Don't think that will matter. So yeah. Anyways, I'm gonna play around with that. And yeah, so that's the little animation that I'm working on. I'm sure I'll figure it out eventually. Um, just have to sit and think about it for a little bit. Like, what am I changing? What is it doing? Um, it's just pretty cool to look at it, though. You know, like play around with it, see what you can manage to do, and implement equations that you're always kind of interested in. Like I've never used this. Like I've only used the wave equation in like you know physics class and physical chemistry, but never actually saw it like put it into action with something. This is pretty cool to actually see it and visualize it. But yeah, so there's some animation with a shader that I can reload now. So I don't have to keep closing the damn program and reopening it, and I could just play around with the shader and see what things do and waste a lot of time because that's what you do when you code, right? If you're learning, anyways. I'm sure once, I mean, I've learned a lot, like just by um, playing around with this stuff, and it's really fun, you know. Eventually, I want to actually do something with it more than what I'm doing now, but it's I think it's good to get a sense of what everything does, how it works, um, how just get familiar with things. Even if it's just, you know, a blank space in one little area. That's probably the best way to play around with things. And then you could implement those in, you know, everything once you have that code, you know. So anyways, that's the program for now, and I'll see y'all later.